Hi everyone. Today let us discuss about iterative deepening depth first search algorithm. It is nothing but mainly used to find the optimal path, that is the best solution from the source to the goal node. Comparing with the breadth first search and also with the depth first search. So in depth first search, what we will do means we will add the child node in the front, whereas in the breadth first search we will add the child node at the back. So this is the major difference between depth first search and breadth first search. And mainly in this iterative deepening depth first search, we are having some 4 core mechanics. So the first one is set limit, second one is execute the DLS, that is depth limit search algorithm, and after that it will evaluate and finally increment the iterations. So here we will move with the help of iterations. So like level 0, level 1, level 2, here we are moving with iteration 0, iteration 1 and iteration 2. So let us discuss with some simple example. So this is the example network. So here A is a source node and G is a goal node. So in the depth limiter search, we have separated like that. We have separated as level 0, level 1, level 2, 1, level 3. So first let us take the iteration 0. In iteration 0, we have to consider only the level 0. So in level 0, we are having only source node. So I am writing that source node A. In iteration 2, we have to consider both level 0 and level 1. So in level 0, we are having A, and in level 1, we are having B and C. So I'm writing A, B and C. In next iteration, we have to consider 3 levels. So level 0, level 1 and level 2. So first, I have to write A in level 0. Then in level 1, I have B and C. After that, in iteration 2, we have to move with level 2. So first I'm writing A, B, and then B's child node, that is D and E. So A to B, B to D and D to E. After that I'm moving to C. So in that I'm writing the child node of C. So F and G, and final G is the goal node that has been achieved in the iteration 2. If it is not achieved in the iteration 2, then I will move on to the iteration 3. So this is the major working of iterative deepening depth first search algorithm, depth limit search algorithm, Next one is advantages. The major advantages are memory efficient, optimal and complete, and best for unknown depth. And the disadvantages are it has repeated calculations and it consumes higher time complexity. So these are the major disadvantages. So comparing with depth limit search. So in depth limit search, what we will do means we will move from A to B, B to D, and if a limit is set means we will move to D to E and further E to C and C to F. But in this iteration, iterative, we are moving on with the iteration 0, 1 and 2. So that means like this. In this case, we are searching the goal node. So this is the major difference. And the next topic is breadth first search algorithm. So as I said before, in depth first search, we are adding the child node in front, whereas in the breadth first search, we are adding the child node at the back side. So let us see one example. So let us consider this network. In this A is the source node as usual and G is the goal node. So the first node, that means node list, I'm having A. So as it is, I have written. In the second step, what I have to do means I have to remove this A, and instead of A, I have to write the child of this A. So what are the child of A? So B and C. In step 2, I have included in the node list B and C. Listen, B and C. In the next step, I have to do, in the next step, I have to write the child node of B because it has been placed at first. So the child node of B is nothing but D and E. As I said before, the child node has to be added at the back. So first I have written B and C. So B and C. So as it is C, I have written in the next step, and for B I had written the, instead of B I have written the child node of B, that is nothing but D and E. In the next step, what I have to do means, so I have to remove this C and I have to add the child of C at the back of D and E. So the child of C is what? So the child of C is D and G. So I have to add at the back of DE. So in the next step, what we have in the node list means DE as it is I have written, and D and G are added. That means child node of C is added at the back. In the next step, what I have to do, I have to remove this D and I have to add the child node of D at the back of G. So the child node of D is what? So the child node of D is C and F. So in the diagram, it has been mentioned wrongly. So this is not the child node. So the child node of D is nothing but C and F. So I have to add the C and F at the back side. So E, D, G as it is I have written, and the child node of D is C and F I have added at the back. In the next step, what I have to do? So I have to write the child node of E. See, but here there is no child node of E. So we have to remove this E as it is. In the next step, what I have to do, I have to move with the next one, that is nothing but D, G, C and F. So the next step, I have to write the child node of D at the back of F. So here the child node of D is what? B and F. I have to add it at the back of this F. So I have written like G, C, F, and the child node of D is B and F. Since at first I had occurred the goal node, so this is the goal node G, so I have to stop the algorithm at this step. So here the correct path is what? So I have occurred the child node, the shortest path is A to C and C to G. So this is the shortest path where I have occurred the goal node. So listen. So this is the shortest path and the optimal path where we have occurred the goal node. And next comes the advantages. So the advantages are it is the simplest search strategies, and it gives the complete solution, and which is also guaranteed. If there are multiple solutions, then a minimum solutions will be found. So if there are multiple solutions for G, if there are multiple root for G, whatever the minimum root, that will be calculated at first. So here the G has been occurred at the 8th step. So the minimum root of G is what? So this is the longest root, this is also the longest root, this is also the longest root, and this is along the shortest root. So the shortest root is A to C and C to G. Next comes the disadvantages. So it cannot be effectively used unless the search space is quite small. So if the space is small, we cannot be used it efficiently. So that is the major drawback given here. So in the next video, let us discuss about cost per search algorithm. Thank you.